If you were to narrow that down into one word, what would you call that word then? No. Yesterday. If you had to pick one word for yesterday, what word would you pick?
Function.
That's it. That's what I'm talking about. Functions. And you know what functions have? Yeah. Every function has a domain and every function has a range. And that's kind of the next step in the process. We started with functions. Now we're going to talk about domain and range. There's like 5 ways you can write them. We're not going to write every single way for every single problem, but you could. So I'm going to let you decide when you want to keep going or when you want to stop. We'll kind of explore maybe for the first 1 or 2 how to write them all. You could write them as an inequality. You could write them as a, starts with an I, interval. You could write them as a number line or a graph if it's got 2 of them. 2 number lines perpendicular is a graph. You could write words, which one of the questions does ask you for. And then there's one more that I think should be here. We're going to get to it later today, but you probably have already seen it because you've been in college algebra. What's the other way to write it? The ugliest way. Yeah, that set or set builder, if you've heard it called that. You don't have to write that. We're going to get there later. I'm just saying, if we're doing a quick overview of all the ways, that's all the ways. Sets, graphs, intervals. Really, those main 3 are the main 3. The set, the interval, and the number line. Well, here we go. Just jump right into it. What does domain kind of mean? Not exactly, but kind of. This is like 9th grade, review from 7th grade maybe, I don't know. Yeah, X. And then there's another thing that it kind of means. There were like 4 things, I think. Input, and then there was one more. Now this is going back to algebra in like high school because you probably didn't do it in college. It's a domain, it's the X value, it's the input, it's the, no, that's a thing, but it's 2 words. I. No, that's the way to write them. Starts with an I and a V. That's it. Who said that actually though? Oh, good job. Independent variable. I don't know. Just good memory. Good thing fun to do. So what are all the X's?
-5.
Yeah, this is not a trick question. It's asking for exactly what you think. 5, 10, 15. That's that domain then. The domain is literally -5, comma, 0, comma, 5, comma, 10, comma, 15. I'm bad at writing these, but squiggly bars. Ooh. And from yesterday, I should have said this first hour and I forgot to the other class. From yesterday, we could just reinforce in our brains a description of a function, which was what? X doesn't repeat. Absolutely. Boom. That's just a thought in the brain as we're just highlighting these. Like, oh, if I would have seen a repeater, we would have been in a problem. We would have had a problem. So if this is teaching and we're teaching on the left and we're answering on the right, also X can't repeat. That makes something a function. But that doesn't change your answer. That's our answer. Cool? Not too hard? It doesn't get that much harder, I promise. Oh, it does. Dang it. We've got ourselves another function. And it immediately got like 10 times harder. I realized that. So the question is, well, what's the X value? What is X? And I suppose because everybody memorized the last page of yesterday's or Monday's notes, everybody knows what that kind of looks like. Right? What does that function kind of look like? You don't have to know it perfect. We're not graphing it all entirely today. What does it kind of look like? A S or a snake or a saddle, somebody told me last class. I think that's the terminology. I just like that little. Looks kind of like that, right? Because it's a cubic function, and that's the parent for the cubic actually looks more like what I'm about to draw in green. But we know that's not the parent, so I'm just gonna write that's kind of what a cubic looks like.
What is it called when it's like this?
Sideways?
And that's the same thing?
The inverse of a cubic, probably, if I had to guess. Because what the inverse does, it takes a function and it flips it around. This is a lot of work. It flips it around the line, y equals x. So if you were to graph the normalist cubic like that, and then you were going to graph the normalist line in the world like that, so that's x, and that's x3, and then you were to reflect it and make it look like a mirror. See how I'm making it kind of look like a mirror?
Mm-hmm.
Is that the function you're talking about, that blue one?
Yes.
That looks like it's going to be the inverse of x3. So that's going to be cube root. That's for free. You don't even have to know that. So what can x be? What could x be on that red line? Could it be 1? Could x be 1?
Yeah.
Could x be 3?
Yeah.
Could x be 1,000,000?
Yeah.
Could x be -3?
Yeah.
Can you think of something bad? Can anybody else think of something bad? 0? 0's fine. Look, it's right there. X is 0 right there. All right, so it feels like it's going to be all real numbers, right? It is. How do we know that we know that is the better question. That's great, yes. What if you didn't know what that function looked like? It's because of what domain tells us to do. If you have a domain and you see the word domain, this is a thought for our brains. And if you had my class, great, you might know what I'm about to say. And if you didn't have my class, that's okay. You've learned it maybe in a different word, and that's fine. That's better, actually. If you see the word domain, what could we look for? Oh, no. Y'all. Like there's 12 of you at least. If you see the word domain in the problem statement, what do you immediately know to start looking for? Oh, no. That corner? What? Luke?
I was going to say bad number.
That's what I was going to say too. We're going to look for bad. No, you haven't, because the real word is probably domain restrictions. And that's when you see the word domain, what we're going to immediately look for. But the way that I like to think of it is they're bad. They make the problem bad. There's 2 of them to start with this year, and then we'll get to the third one way later. There's 2 bad numbers, or there's 2 domain restrictions. And now you know where we're going? Yeah, okay. So there's 2 things that can make it bad. First one, or they don't have to be in order, but what could make something bad? This is from the 3rd grade. Your teacher in the 3rd grade said, you can't do this. This is bad. Dividing by 0 is bad, right? Any number in the world, actually not even a number, anything in the world, you could put a blank box there. I just always write a number sign because it looks cleaner. Anything over 0, bad. There's another bad thing in the math world, or a domain restriction in the math world. Anybody else got the other bad thing in their brains? Square root? What about it? Negative thing down there, right? Cool. And that's it. That's all you have to do. That's how you know that this is all real numbers. Because look at the actual function up there. I know we've written a lot now. This is all teaching. That's all the problem. Does that function have a fraction? Nope. Does that function have a square root? Then guess what it is? All real numbers. And that's kind of the way we do it. We look for those restrictions. And if we don't have them, it's everything. A better way to write all real numbers is probably parentheses, negative infinity to infinity. Or maybe if you wanted to do it in a number line, it would look like a completely shaded number line. It's kind of a silly way to write it. I like the interval notation for all real numbers. Or just writing all real numbers. Or if you want to be really cool, you can say x, epsilon, all real numbers. You don't have to do that. That just means x is an element of the real numbers or the set of real numbers. But if you're asking me, this is the best. That lets me know exactly what you're talking about. You're talking about every number from the smallest one you can possibly think of to the biggest one you can possibly think of. Cool? Lots of other examples of all real numbers. The regular parabola, the regular line. What else? Not the square root function, because it can't be negative. And that actually falls perfectly in line with that. Not the rational function, the one that looks like that ugly horseshoey one, because it can't be 0. And that falls right in line with that. So then I see the word domain. I think bad numbers. I look at my problem. And do we have any bad numbers? Absolutely. So I see the word domain. I think bad numbers. I split it into 2 sections. I think a number over 0. I think a square root of a negative. And you know what I see right away? I see a fraction. And so we're not solving, because this isn't like a solve for type thing. This is just a consider. So if it's bad to have a number over 0, what do we want? We are going to force to be true something about that equation. We're going to say, you know what's not allowed to happen? And I guess this would be step 1 of this tree. If we're making this domain tree, it's domain, bad numbers, split into 2 types, and then this is the last step of it. This is the last row of that tree. If it's a bad number and it's a fraction, you know it can't exist. What can't be true? The denominator. That's exactly what we're going to write. Better not be 0. The denominator better not be 0, or can't equal 0, or is not equal to 0. And then we're going to actually go over to the problem and write that. So what is the denominator? Big old math word. 2x minus 1 better not be 0. And I leave that to you to solve normal style. Race. First one to get 10 points on the first test. I lied. I'm not giving you 10 points. Okay. So you're saying you move the 1, and you got 2x better not be 1, which means x better not be 1/2. But that's not a domain. That's just a fact. X better not be 1/2. Cool. Okay, I like to start with the number line. You don't have to. That's just me. There's only one number that we have, so there's only one number we need, 1/2. And so what do we know about this number line? It's literally every single thing on that number line except for 1/2. That's number line format. That's the first format. Second format. What's the smallest number this thing can be? Negative infinity. What's the biggest number it can be? Positive infinity. Are there any cutouts along the way? A cutout, I kind of like to think of like that U cuts it out, right? The union or united. It's cutting out that number. And what number is it cutting out? On both sides. So our 2 intervals are negative infinity to 1/2. Cut it out. It's not there anymore. 1/2 to infinity. That U is like let me get through there and split these 2 things apart. We're uniting the 2 sets. Cool? For the sake of, let's do it. I'm not expecting you to write this or memorize this, but so that it's on here. X bar, right? X is smaller than 1/2. Or this is why I'm doing this, is for that keyword right there. How do you write union as a word? Or X is bigger than 1/2. Close the set. Though I'm telling you right now, just know the interval thing. I'm pretty sure my open math only ever asks for intervals. On the test, all you need to know is intervals. If you just get intervals down and get good at them, we're happy with that. Okay, zoom out a little bit. Pause for a second. bad numbers. We just did the first type of bad number. We wrote it 3 different ways. You only need one, but we wrote it in all 3. The red box is your answer, in case you're like, that's a lot of writing. That red box is the important part. Just like that green. Oh, I should highlight it green. That's what I'll do. Nope, because then you can't see it. Leave it alone. Cool. Time check. 30. So we got 20 minutes. We got to go. Second type of bad number. So we did the first type of the tree. I see the word domain. I jump down and I think bad number. I break it into 2. I've got number over 0. You don't have to write this every time. I just do. I do it every time. I don't know. It's just a good way that you're jogging your memory every time. I know how to do these types of problems. And we've got a negative number underneath it. This is the second type. This is a little harder of a thinking question, but what do we want to be true? Or what do we need to be true? This one has a little more thinking behind it. We need 5 plus 2x to not be negative. Well, but pause. What about 0? Can it be 0? This is why there's an extra step of thinking. Can the 5 plus 2x be 0? Okay, that's allowed. Okay, so now the next step of question is there a math way to write 5 plus 2x is not negative? 5 plus 2x is not negative? Is that how we do it? That's not helpful for us. There's a sign, right? Greater than or equal to a. That's the math step. So what did we actually write? We wrote the inside of root greater than or equal to 0. That was the domain step that we did. The inside of the square root greater than or equal to 0. And now we just do some math stuff as well, right? I'll leave you to do the math stuff. Have fun. Ooh, there's just actually this doesn't happen, but it could have, and that sucks that we don't get to talk about it right now. But negative multiplier divide flips the sign. Maybe we'll have to. Maybe there's one in your homework. Be careful. We don't. I know this is annoying that the practice problems don't give you every single possible situation. But we'd be here all day.
I have a question. Did we do number line, like word problems in this class?
I don't know. That's a hard question to answer. It depends on the unit. Depends on the words. These problems have words in them. Domain's a word. I don't know. That's a hard question to answer. Oh, I didn't leave myself any room. I'm going to just do one format for the sake of time. What's that one format? Interval, probably. How do I write x is bigger than that number? I go that number, negative 5 over 2, comma, infinity. Does that feel right? No, did I mess up? Why is it not right? Oh, scared me. Hey, I do often mess up. I promise it will happen. Cool. Not too bad. The great news is the next page literally is just the exact same thing. It's on there twice. Same thing we already did. There's no math on this page. It's just, hey, these are the ways. This is a quick review. You can write it on a number line. You can write it as an inequality. You can write it as a set, or you can write it as an interval. Interval is the test. Please learn interval. Interval is also my open math, so that's nice. But this is how the things look in all the different cases, all the situations. Infinities, not infinities, open circles, closed circles, inclusive, exclusive brackets. That's everything. So if you want to go back and refresh your mind on how any one specific case looks, that chart has most of them, if not all. And then some official definitions, which we've already talked about plenty. We don't have to. So here's what we're going to do. What time is it? 35? Oh, yeah, we got 5. Sweet. I'm going to give you about a minute. Talk to a partner. Talk to a friend. Be ready to report an answer for try at 5. I'll give you like 1 minute exactly. Turn on some music so it's not so awkward. You can talk to each other. It's allowed. Unless the music's off. You can keep going and do that chart if you want to, but I really just want these 3 because I want to get your ideas about them. Turn around, ask the person behind you. Don't be a hero. One minute, starting now. Words is hard. There's no right answer. It's just words that you can use. Some keywords are between, or, up to. I don't know. Words is there's no right answer. Ours went first. Good job. Not too bad. Well, the words are just words. It's not a perfect answer. All right, we're back in. What are you laughing at?
Because we made the same face. We were both like scratching our heads except over.
Okay. We're back into it. Someone with a hoodie on. If you don't have a hoodie, you're free from the first one. Somebody that has a hood, don't take it off. Anybody with a hood, save us from the words one. Anybody with a hood, help us with the words one. You can get help from a friend as you go, but get us started. I'm not in a rush. Thank you. Negative infinity. I guess I could. That's not. I'm gonna write it. Negative. I'm just gonna write the thing. Negative infinity to negative 2. Union negative 1 to 3. Okay. I'm gonna stay with the hood people. Anybody that still has a hood? Is there anything important? There is. I'll tell you, there is. That's a good start. But there's some important information missing from it that we actually do need to know. Yeah, how do we convey that? Okay, the word including, right? That would actually be a really good word. Negative infinity to negative 2, including negative 2. And then, I should have erased that. I should have. United with. Another way to say union is united with, but I'm okay with you leaving union for if I can get it on the paper. Sometimes you'll see the word united with. Negative 1 to 3. And then what were you going to say? Including negative 1, not including 3. That's fine. A little messy in the way I wrote it, but that's okay. As long as you're getting a point, all the getting across all the points. Another way we can say it is every number up to -2. Ooh, that would be fun. Up to and including -2. That's just a fancy way to say it. I don't know. I'm just thinking of a way that else you can write it. And then you could also you could use the word between. Every number between -1 and 3, and also 1, and also negative. I don't know. Words is there's no right answer. It's just get all the points across so that someone can know exactly what set you're talking about. Because what you did would give me all the blue lines, but it wouldn't tell me what happens at each point. Awesome. All right. Somebody wearing black. A lot of you. That's a lot of you. Somebody wearing black. Talk to me about this set builder. We gotta hurry or we're not gonna get our break. I was hoping to get to that bottom thing by 10 minutes left. Oh, it's not black? Mm-hmm. That's black. Mm-hmm. That's the black shirt. You can tell me the first symbol. The squiggly line? Okay, thank you. Somebody else? I'm going to stay with the people wearing black? Yeah? See, it's just not that hard. You probably, and then the bar, which means is an element of. What were you going to say? Oh, such that. Yeah. X, such that X is in this, or X is an element of this set. That's where we got stuck. That's where you all look at each other and start laughing. Yeah. You could start there, but some people don't. But I'm going to write it and then show you that we could erase it. X is, you're going to say greater than? Or equal? No. Just, it can't be equal to X. And then what goes on the other side of that X? Another sign? With the 2? That's true. And now what I was going to tell you is some people just write that. It kind of means the same thing, right? X is less than 2? Yeah. So you wouldn't get points off if you wrote that on a test. You're getting full credit. It's true. But you might see it if it were a multiple choice test with that big chunk left off because it's the same thing. Cool. I'm going to leave it up there, but I'm going to put a little line through it so you can know it. You might not see it. Or, and then what are we looking at? Black shirts. I gave you the or. That was pretty nice. Nice. Less than. Awesome. Perfect. Thank you. That was the hardest one. Now somebody that wasn't in the first 2 groups hit us up with that interval notation. You tell me?
Yes.
So you're saying not that? How'd you know?
Because the circle is closed.
That circle means bracket.
Okay. And then the unit bracket -1, 3.
Good. United unison talking. That was good. Okay. We need to get rolling. We're going to skip 7, but we need to do 6 because we technically haven't done a range one yet. They just didn't give us very many because domain's way more popular. But they technically haven't given us a range one yet. So y'all holler out the domain and then I'll feed you the range. What's the lowest X? Love it. Does it include it or not? That's kind of... Yeah, I think so. They don't give us the dots. Let's pretend like they do. Promise you, if you're taking a test, I'm giving you those dots. Or the open dot. You'll know. You'll know very well which... 1950, and what's the furthest one?
2000.
Okay, that's a great domain. That is all of the years that this graph talks to us about. That is, what could X be? Now the range is a little different. What's the tiniest range or the lowest range? It looks kind of like 49, doesn't it? I don't think it's 45. I do too. Now this is where it's a little different. The question we ask our brains is not, what can y be? Because y could be anything in the world, right? The question we ask our brains is, what does that make y? What does the domain turn y into? Or when we were talking yesterday and someone said input turns into an output. What does that input, 1950 to 2000, make the output? So what is the biggest y value? It is. In the temptation, which I see a lot of times, it's okay. This one's a little easier. But the temptation is to go to the same endpoint, right? That's just the most common mistake or hiccup that I'll see is that they'll go to that same green line. So this start point was the same, right? So your brain's like, oh, it's just the endpoints. Let's go to this endpoint and check that one. And that's a taller y. If we stopped at 78 or so, we'd be missing some numbers. All right, we can do it. I know we went fast today. It won't always be like that. We're going to skip 7. It's exactly like one we've already done. I believe in you. You can do it because we got to do this piecewise. Because just like yesterday, it's on the homework. It's on homework 2, and someone was like, hey, I tried homework 2, and this was on there. And I was like, yeah, that's why it's on here. So you've seen piecewises before. They're those little squiggly lines with a bunch of different functions all mashed into one function. We're going to graph them. And we're going to graph them by just kind of looking at the borders and taking it slow. And doing the easy ones first is, I think, the best thing. So, before even looking at the functions, which are in the middle's the functions, I'm going to look at the boundaries. So there's probably 2, because there's 3 functions, which means there's 2 boundaries. What are the 2 special looking numbers? It looks like -1 and 4 have something special going on, yeah? They do. They're the boundaries. So I'm just going to draw a dashed line all the way down, and the dashed line all the way down at 4. And then I am going to ask you to pick which of those 3 functions looks the easiest to graph. A cube, a number, or a square root? Me too. And does that look like it's in the middle, or the front, or the back? But just based on the formula and the numbers there, we're looking at it. And I'm thinking -2 looks like it's in the middle, right? So I'm going to the middle chunk, and I'm just drawing a line at -2. And then I'm using the skills that we learned today to know which one gets a closed circle and which one gets an open circle. If I'm looking straight at this middle section, which of those 2 sides is closed or shaded in? The left side, because of that symbol, which means the right side is open. I mean, I guess they could both be closed depending on the sign, but in this case, it's open. All right, so now what's the next easiest function? The cubic or the square root? You all went home and memorized that little paper on the back that said functions you need to know, and so now you know what they look like, right? Remember on the back of that paper? Said functions you need to know, and nobody looked at it. What does a square root look like? I'm going to start with square root because it's my favorite. It does. It looks like a parabola, except for it's sideways. This is negative. Your parabola, x squared, -x squared, x cubed, -x cubed. I'm talking the square root is this, but sideways. But now from yesterday's lesson, a sideways parabola is, oh no, it's not a function. A sideways parabola is not a function immediately, right? So what do you have to do? Kill the bottom half out of there. And now we've got what that function looks like. A sideways parabola, but only the top half, because it's not a function if we don't. So I'm going to draw that. Looks like it goes to 1, 1, 2, 4, 3, 9. Oh, wait, something's bad there. That middle chunk. So it's got to go away. Boop, just like that. It doesn't have to be perfect. You don't have to be a great drawer. It's okay. And then last but not least, we'll finish. Oh, we're going to finish perfectly on time. What does the cubic function look like? Someone already said it today. Looks like a snaky thing, right? So if we're doing, here, I'll circle that one red. If we're doing the blue chunk, I'm starting in the middle because I like to, even though I'm going to erase it later. So my pens are bad. And it kind of looks like it goes to -1, then just goes down fast, right? I'm going to erase the middle section. And open dot or close dot looks like it's open.